Hello everyone, hope you all are doing well. So today we are going to discuss the next topics of our geography series, and from today we are going to start the geomorphology part of geography, and the topic we are going to discuss today is the interior of earth. Okay, so from today we will be starting the interior of earth. So first of all, what is geomorphology? You should understand. So geomorphology is the study of lithosphere and its shapes. Study of lithosphere and its shapes. So just keep this definition in mind so that you do not confuse what geomorphology is. Okay. So now let's start the interiors of Earth. So before starting, I must let you know one thing that please do make your notes. It is very important, very crucial because the notes you will make will highly be helpful to you during your revision days. So please do make your notes. Now let's start the interior of Earth. So before starting, I must let you know about the sources. There are various sources through which we get to know about interior of Earth. There are certain direct sources and certain indirect sources. So direct sources are those sources in which we are able to see, feel, look about the materials of interior of Earth. So how can we see about the interior materials? First of all, volcanic eruption. Volcanic eruption. Here the interior materials in the form of lava and magma came out. So you can observe that. Okay. Secondly, we can do deep mining. There are various deep mining projects which have happened in the past and will be happening in the future. Okay, there are various deep ocean drill projects, deep ocean drill projects. So these are all the sources of these are all direct sources. Okay. Now there are certain indirect sources also, so that we can observe geothermal gradient. We can observe geothermal, that is changes in temperature as per the materials. Geothermal gradient. We can observe the magnetic and gravity studies. Magnetic and gravity studies. We can research on meteorites. Okay, various meteorites fell on Earth. We have collected samples from various meteorites. So how can you get the indirect sources from meteorites? Because during the evolution of Earth, there were several meteorites which were also evolving. So as they have evolved at similar time scale of their formations in the geological history, so we can get to know what kind of materials are present in meteorites, and through that we can analyze what kind of materials would be present in our Earth. So meteorites is another important source. Next important source is the seismic waves, that is earthquake waves, which travel in different densities. So we all know that there are P waves, S waves. So S wave is not able to cross the outer core because of its liquid or molten nature. Okay, so you can see through seismic waves we can also get to know about the densities of various layers of Earth. So these are all indirect sources. So I hope you understand what direct sources are and what indirect sources are. So through the help of these sources, we are able to absorb a brief structure, a rough structure of the interior of Earth. Okay, so we will see the interior of Earth. I have made it before only so that there is not much time wasted in drawing these things. So this is a kind of, when you cross section the Earth, you will find layers like this. Okay, so the first layer is the continental crust. This is continental crust. Okay, and the layer below it is the oceanic crust. That is ocean's layer, ocean's surface, and that is continent surface. And again, when we go below, we find upper mantle. Upper mantle. And this is also upper mantle only. Let me explain. And in between upper mantle, in the layer of upper mantle only, in some portions of upper mantle, we will find asthenosphere. So this asthenosphere is the region for the coming of lava and magma. Okay, so there is this asthenosphere is present in upper mantle only, remember it. Then going down from upper mantle you will find lower mantle, and when you go down more you will find outer core. So this is the portion where the S waves are not able to cross, and you are observe the shadow zone of S waves. We have discussed those things in earthquake, so you can follow that. So lower mantle, outer core. Then we have at last we have inner core. Inner core. So these are the layers of Earth. Now, when you go down, you will find that the densities are also changing. Here, the density will be around 2.4 gram per centimeter cube, but as you go down you will find that the density of upper mantle is around 2.7 gram per centimeter cube. If you go more down you will find that the density of asthenosphere is around 3 gram 3 gram centimeter cube. Then we go more down, it is 3.5. Then we in lower mantle you will find it 5 to 8. Okay, 5 to 8. When you go to outer core it will be around 10, and in the inner core, at the layer of inner core, it will be around 15 gram per centimeter cube. So what you observe that here that whenever you go down, the densities is increasing. That is, the more denser layer are at the inner cores, and the more and the less denser layers are at the crust part. So this is what you need to remember. Now there are certain parts. So till upper mantle it is known as lithosphere. As you go below lower mantle, this is asthenosphere, obviously asthenosphere. Then this is mesos mesosphere. As you go down you will find this layer is also known as pyrosphere, and our core is part of barysphere. Okay, so these are the various layers of our uh, crust, or you can say the interior of, or not crust but interior of the earth. Now there are certain regions where there is change in densities, and that is why we have named them as the there is some discontinuities, okay, due to the changes densities. So we will see what kind of discontinuities are present where. So around 25-kilometer mark there is certain change of density, and there we will find conard discontinuity. Discontinuity. So conard discontinuity is present between continental crust and oceanic crust. As you go down between oceanic crust and upper mantle, you will find Moravik discontinuity. Moravik discontinuity. Moravik discontinuity at around 35 kilometers. That is between oceanic and upper mantle. Between upper mantle and lower mantle, you will find Rapiti discontinuity. Rapiti. Okay. And between lower mantle and outer core, you will find Gothenburg discontinuity. Gothenburg discontinuity. And between outer core and inner core, you will find Lehman discontinuity. Lehman discontinuity. So these are the famous discontinuities from which question could be asked. And you should remember these. These are the very important ones, discontinuities. So here at 35 kilometer, then you can find repeated discontinuity at around 700 kilometer down, Gothenburg at 2900 kilometer down, and Lehman at around 5155 kilometer down. So these are discontinuities which you should remember. So these are the very important ones. Do remember this. You can also remember a code name, that is LGRMC. LGRMC. From down to up it is LGRMC. And remember that Lehman is between inner and outer core. Gothenburg is between outer and lower mantle, outer core and lower mantle. Rapiti is between upper mantle and lower mantle. Okay. Then Mohorbrig is between oceanic crust and upper mantle, and Conard is between continental crust and oceanic crust. So please remember this, it is very important. So this was about discontinuities. Now let's see in detail about different layers. So the first important layer is the crust. So there are various elements in the crust. So we will see the dominant elements. So I am writing the name of elements. The most dominant element is the oxygen in the crust. Do remember, it has been asked several times. The second most dominant element is silica. Then we have alumina, third dominant. Then we have iron. Then we have calcium. Then we have sodium. Then we have magnesium. And then we have potassium. So this is from higher to lower, that is amounts. So oxygen is the most dominant, and in the table the potassium is the least dominant. So do remember at least top 3, 4, 5, because they will ask you. They have asked in previous examinations in CDS, CAPF. So there are high chances that these questions can repeat in CSE also. So this is the important table which you should remember. That is the dominant elements of the crust. Now, crust is also divided into two types, that is continental crust and oceanic crust, as we have discussed. So, first of all, we will see about continental crust. So, what are the features of continental crust? So, these are made up of lightest elements of Earth, made of lightest elements of Earth, lightest elements of Earth. This is also known as Sial layer, that is rich in silica and alumina. Sial layer. Then there are various dominant rocks present in this layer. The dominant rocks are granite and rhyolite. Granite and rhyolite. And the average age of continent crust is around 2000 million years ago to, or you can say 2000 million years ago, or you can say it as 2 billion years ago. 2 billion years ago. So you will observe that the continental crust is more aged as compared to, more older as compared to oceanic crust. We will see the reason when we will learn about various type of theories. Okay. Later part of the our geography series we will learn about it, and there the concept will be cleared why continental crust is more older than oceanic crust. So these are the common features of continental crust. Now see the features of oceanic crust. Oceanic crust. So these are denser rocks, made of denser rocks. Continental crust were made of lighter rocks. Continental crust was Cr layer, it is Sima layer, that is silica and magnesium. Sima layer. Then the dominant rocks here are basalt and gabbro. Basalt and gabbro. Why basalt? Because of the continuous volcanic eruptions on at the mid-oceanic ridge. We will discuss in the theories part. Don't worry. Then it is very young compared to continental crust, younger, very young compared to continental crust. Continental crust. Its average age is 200 million years ago, whereas the average age of continental crust was 2000 or 2 billion years ago. Okay, so this was about crust. We have understood about continental crust and oceanic crust. Now let's move to the next layer, that is mantle. So mantle constitutes around more than 80% of Earth's volume. So it is the most dominant layer of Earth. More than 80% of Earth's volume. The important minerals here are olivine, pyroxene, plagioclase, plagioclase. Then we have amphibolite, So these are the important minerals. There are certain important rocks also. Important rocks. So the important rocks are peridolite. Then we have serpentinite. Serpentinite. Then we have hornblende. Then we have granite, or not granite, granulite. Then we have geolites. So these are the important rocks. So mantle is also divided into two parts, that is upper mantle and lower mantle. So first of all we will discuss about upper mantle. Upper mantle. So when you observe the upper mantle in the cross section, you will find that the uppermost part is the part of lithosphere. The uppermost part of upper mantle is part of lithosphere. That is, it is among top 100 kilometer. Whereas the lower part is part of mesosphere. Lower part is part of mesosphere. You had have observed here that, yes, here that the upper mantle is part of lithosphere, whereas the lower mantle is part of mesosphere. Sorry, not pyrosphere, it is part of mesosphere. Do remember it? Okay, mesosphere. Then it's another layer. Let me correct here one thing. So this lower mantle is part of mesosphere, outer core is part of pyrosphere, okay, and this inner core is part of biosphere. Do correct it, there is a silly mistake here by me. Okay, the upper mantle is part of uh, lithosphere, okay, this lower mantle is part of mesosphere, okay, some parts of upper mantle and lower mantle are part of mesosphere. To remember it, okay. Now another important layer of upper part is upper mantle is asthenosphere. So what is this asthenosphere? So this is the semi, it is in semi-molten state. Semi-molten state. There is high radioactivity in this layer. High radioactivity. Radioactivity. The high thermal energy. High thermal energy. Here there is reduction of overlying pressure. Okay, reduction of overlying pressure, and this reduction leads to melting of melting point of rocks. Okay, this decreases the melting point of rocks due to the overlying decrease in overlying pressure. There is decrease in melting point of rocks, so rocks are melting quite fastly in this layer, okay, and this layer is the part of plate tectonics, that is plate moves on this layer only. Plate tectonics, that is the lithosphere plates move over it, move over it. So these are about important points about asthenosphere. So please do write down it. Now let's move to the next part of mantle, that is lower mantle. Lower mantle. So in lower mantle you will find a very important thing happening, that is magmatogenesis. That is the birth of magma. Magma takes birth. This magma only moves to asthenosphere, and from there it converts into molten stages, semi-liquid stages, and then comes out as lava from the volcanic eruptions. But the birth of magma is in lower mantle. These region are the region of hot spots, that is hot spots, or you can say mantle plumes. Mantle plumes. Genesis here, that is the birth of hot spot. You have heard about various hot spots on the various regions of Earth. Okay, there are various mantle plumes. So all these start here or generate here. The genesis is here only. Here you will also find that Conventional current move in lower mantle. Conventional current move in lower mantle. So these are the important points about lower mantle. Do remember about magnetogenesis, spots, mantle plumes, and conventional currents. Okay. Now let's move to the next layer, that is the core. Core. So core is the densest layer. Okay, here you will find the densest minerals and rocks. Densest minerals and rocks. This layer is known as Nephi layer. That is, it is rich in nickel and iron. Nickel and iron. So core is also converted divided into two parts, that is outer core and lower core. So outer core is the liquid state. Liquid state, and this we have found through the shadow zone of ash waves, because the ash wave is not able to travel in liquid areas, okay, liquid parts. That is why we found out that the ash wave is not able to travel through the outer core, so it might be liquid, it might, no, it is liquid. Okay, deduced due to the shadow zone of ash waves. Deduced due to the shadow zone of ash waves. Ash waves are the earthquake waves. Similarly, you will also find that electromagnetic currents in outer core, there are electromagnetic currents in outer core. Currents in outer core, it lets our earth to behave like a bar magnet, behaves like bar magnet. That is why there is a magnetosphere encircling the earth. Magnetosphere encircling the earth. So we will discuss in very detail in the coming lectures about magnetosphere, what is aurora borealis, what is aurora australis. So all things will be discussed. Currently, just remember that suppose this is Earth, this is the core. So outer core, there is electromagnetic currents which lets the Earth to act like a bar magnet, like this. Okay, so a magnetic field is around the Earth. So this is about core. I hope you understand. Do remember the important points. Now, as we have discussed the discontinuities, so write 2 and 2 points about discontinuities. It will be important. What are these discontinuities? We have discussed about Lamb and Gutenberg, other discontinuities here. So these are the discontinuities. So let us see what are these discontinuities. Discontinuities. So these are the area of transition in interior of Earth. Area of transition in interior of Earth. In interior of Earth, where there are changes in densities, where changes in density, mineral composition and rock composition occurs. Changes in density, mineral and rock composition occurs. Rock composition occurs. So there you will be able to find discontinuities, and they are demarcated on the basis of spikes observed in seismograph. Demarcated on basis of spikes observed in seismograph. So whenever you see the seismograph, it will be like this. There will be certain spike, then it will move like this. There is certain spike. So these spikes are due to the change in densities, and due to the observance of these spikes, we are able to demarcate various discontinuities and name them. So this was all about today's class. In the next class or in the next video, we will see about rocks and minerals. So I hope you understand various things. Do remember the discontinuities here, it is very important. Do remember this abundance of or dominant elements of the crust. These things have been asked in previous examinations, so you should remember. So that is all for today. If you like it, please press the like button. Please do share and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis, and if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.